Okay, so we've got a triangle that looks a bit like this, and they tell us that if we say that that's A, B, C, that's theta, AB is 10, AC is 5, and it also tells us the area is 15. Now, find two possible values of cos theta. Well, what you need to realise is that the area can be worked out using the formula of the half of the product of two sides times by the sine of the angle in between. So the area is a half of 5 times 10 times sine of theta. But we know that's equal to 15. So we can get an equation for sine theta. Sine theta is going to be 15 times 2 divided by 50, which is 3/5. Now, what you could now do, if you had to find the angle, would be to do inverse sine or arc sine of 3/5. And because the sine graph looks like that, and supposing, and that's 1 there, so 3/5 is going to be about here, you should be able to see that there are going to be two possible angles. It could be that angle there, or it could be that angle there. Okay, now, so there are two possible angles that are going to fulfill that criteria, and each of those angles is going to have two different values of cos theta, possibly. So that's one way you could do it. The problem with that is you might end up getting a rounding error, because you're going to have to use your calculator to find what the angle is, and then you're going to have to take the cos of each of those angles. So there's a better way to do it, and the better way to do it is to use a very, very, very important identity, and the identity is that sine squared theta plus cos squared theta is identical to 1. Now, the reason there are 3 lines there rather than 2, that means is because it's identical, and what that means is it's not an equation that depends on the value of theta. It's always true no matter what the value of theta. It's always true that sine squared theta plus cos squared theta is going to be equal to 1. So, but we know what sine theta is, so we know what sine squared theta is. Sine squared theta will be 9 over 25, plus cos squared theta is going to be equal to 1. So cos squared theta is going to be equal to 16 over 25. So cos theta is going to be equal to plus or minus the square root of 16 over 25, which means that, if I carry on down here, which means that cos theta is going to be equal to either 4/5 or minus 4/5. And there you have the two possible values of cos theta. Now, let's carry on. It says, given that BC is the longest side of the triangle, find the exact length of BC. Well, where you've got two sides of a triangle and the angle in between, and you want the other side, you're going to have to use the cosine rule, and the cosine rule tells you that BC squared is equal to 5 squared plus 10 squared minus 2 times 5 times 10 times the cos of the angle in between. Now, but however, we've got two possible values for this cos theta. It's either going to be 4/5 or minus 4/5. We want BC to be the longest we can get it, or the greatest we can get it. So, and that's going to We're going to get that if we choose minus 4/5 as the value of cos theta. So we're going to get 25 plus 100 minus 100, and if we use minus 4/5 it looks like that, which is 125 plus 400 over 5 is 80, which comes to 205. And in the question it says it wants us to give the length as an exact length, and remember that means it doesn't want decimals, it wants it either as a whole number or a fraction or as a surd. So all we can do is say that BC equals the square root of 205, and I don't think we can simplify that any further, and so we can just leave it as that.